Hi guys, welcome to this advanced mathematics YouTube platform, especially for pure maths, applied or combined maths, A's level, A2 level. So important video series, all theory and revision type question solving for your future exams. So you can get a high advantage and opportunity of this video series. So please subscribe and send it to all your friends, colleague, all teachers. You can send to your group, maths class group and all. Okay, a fantastic day today. We'll see one, I think the complex one, pure mathematics and apply two questions. One at the beginning, I'll show the complex number or locus argon diagram question. Very interesting problem. The problem says on an argon diagram, a complex number z moving such as z plus 3 plus 4i modulus equal to 3. And find the maximum minimum value of mod x. Maybe the system problem is like that. Find the maximum and minimum of mod z and find the ratio maximum divide by minimum, highest and least. Okay, dear guys, I'll show some small theory part how to convert this question into an exam paper answering. You know, the local bodies, this problem comes structured paper, 25 marks in pure mathematics paper or paper 1 part A. Okay, so if I show at the beginning, I give some small part of technique or the theory. I hope you have covered all entire syllabus of complex number and waiting for my this video series. This video series mostly suitable for revision type questions, all are expected for future exam. Furthermore, you have to read. Okay, see at the beginning, what is modulus of x? Z. You know, mod x absolute value. What is the modulus of z on an argon diagram? Or define what is mod z. A simple meaning, I am giving a simple method. Mod z mean complex number moving in an argon diagram. Before that, what is an argon diagram? A simplicity, that is like a coordinate plan. Coordinate axis x and y, where we shown that complex number. We are marking x comma y coordinates, that is in perform that we can rearrange to complex form, complex number. We have so many complex number forms, Cartesian format and the polar format and exponential format, e to the power format, like many more. Okay, so actually the students, mod z, the mod z mean, noted clearly, distance from the origin. Mod z mean distance from the origin to the complex number z. I can further explain this like that. We can write this like form. So from the origin 0, 0 point, the distance to the complex number z, right? That's the meaning of the mod z. Okay, right. Next item I can give you that mod z equal a. What is this equation on an argon diagram? Mod z is a, right? This equation describe a locus on an argon diagram. It's a circle, right? I won't go long part deep learning here. Small point by point. You noted, if you don't know the final chance, mod z equal a means the circle where origin is the center, a is the radius, right? Mod z equal a means which is a circle in a complex number, center, origin, radius a, right? Or this also I can show like this, another simple method we can write like this. Oh, see, therefore simple, this is center, here radius, circle. Similar, dear, z minus z1 equal a. Okay, z minus z1 equal a. What? So here I said origin, center, radius a, circle. So here z1 is fixed, constant, fixed, not moving complex number, right? Z is moving. What the locus of this pattern? Once again, circle, z1 center, radius a, right? Z1 center, radius a. So therefore the complex number moving on that Argand plan or Argand diagram, right? Okay, now come back to this problem. They say complex number Z, describe the locus or the equation Z plus 3 plus 4i equal to 3. That is a circle. If you follow my earlier, I said Z minus Z1 equal to A. Z1 center, A is radius, right? Therefore, can I rearrange this format? See from the beginning, Z minus 3 minus 4i, okay, equal to 3, right? Compare this. This is center radius 3 complex number. This is center radius 3 complex number circle. So you know this mean minus 3 comma minus 4, right? Minus 3 comma minus 4 as a center of the circle and radius 3. So I can do a rough diagram of this complex number on an Argand diagram. This can be done using many methods, algebraic method, trigonometric method or Argand plan. So most easiest way for examination, candidates can use Argand diagram method because the question comes 25 marks. Small part is available to space, complete the space. So you can go many pages for this. As a homework, you can use it many way and tally the answers and check whether answers are same one or the all equal solution, right? But the exam part on an Argand diagram, study the easy way. So can I roughly draw where this circle on an Argand diagram? This is the Argand plan. We call this is a real plane, real axis, imaginary axis, okay? Real axis, x-axis, imaginary y-axis, or I can mark x, y, no matter, right? Okay? This is origin, right? So where minus 3 comma minus 4, somewhere here. Radius 3, see radius 3. If I mark minus 3 here, here minus 4, this is 4, then radius 3, yeah, radius 3 mean the circle comes something like that, it won't goes out of that side of the y-axis, right? Radius here, this is completely 3 units. Is it okay? This is 3 units. And if I, yeah, this 4 here, this is 4. Here, this is 4. Okay, the coordinate check will you the diagram form, is it okay? 3 comma 4 minus 3 units. 3 units here. Here 4. This is 3. This is 3. So how this diagram? Radius 3. Center minus 3 comma minus 4. See another picture if I draw here, it comes like this. See this value. This is minus 3 here, minus 4. Radius 3. So it should be 3 years. But here should be 3 years. But this is 4. Therefore, no chance of touch the axis like this, is it? This is minus 3. Okay, no problem. And this is 4. Therefore, this is the picture, right? Okay. Now, I said the question is find the modulus Z. What is modulus Z? Distance from the origin. Distance from the origin, right? So, this is the locus of the complex number Z, right? Practice and see this question properly noted clearly. You can answer any type of hereafter similar pattern. I covered all the circle locus. So where is Z complex number? Here or here, everywhere. Infinite chance of points for Z. Now what the question is, what the small answer of distance of Z and maximum answer from the origin, right? Okay, therefore dear students, see if I draw through the center, this is minus 3 comma minus 4. Okay, I mark this point is A. Here I mark the point is B. Right, check will you. So the distance, we know distance mean what as a displacement, straight distance. O to A one distance, O to B another distance, and also we have some here, everywhere we have some distances. but least and the highest, it should be a diameter line, extreme of the 2 points of diameter. This is small point distance, here the large. That's the technique, right? Therefore, dear, no doubt hereafter, this is 3, radius 3, radius 3. So I need to find the center. Can I mark the center C? Center is C, right? So C coordinate is minus 3 comma minus 4, right? C coordinate minus 3 comma minus 4. So what is OC distance? That is coordinate. It is argon. This is a coordinate plane. Therefore, you need some coordinate geometry, right? So what is OC distance? Square root of x1 minus x2 square plus y1 minus y2 square, right? They have no problem. 16 and 9, 5, square root 5. OC value is 5, right? Now they say Z maximum distance from the origin is O to B, right? O to B, okay? OB, okay? What is OB? OC plus radius. OC plus radius, okay? OC plus radius. So 5 plus 3. 5 plus 3 is equal to 8. So the biggest distance from the origin to complex number Z, 8 units, right? Now take a Z minimum. Find the Z minimum answer somewhere here. So this part, right? That is OB minus radius. OB minus radius. So you know the OB is 5 minus radius 3, right? Therefore 2. Okay, that's all. So now you answer the ratio between the highest and the least. Okay, 8 divided by 2, 4. The answer is 4. I think a superb explanation. Follow this method, or as a homework you can answer, say z equal x plus y, and rearrange the equation in terms of Cartesian equation. It becomes circle, x square plus y square, something like a square, or x square plus y square plus 2gx plus 2f5 plus c equal to that format. Okay, this is the complex number problem. I hope you understood clearly. So newcomers, please subscribe this and send it to you. Take the full advantage of this video series. Right, come back to next problem. One probable applied mathematics, projectile motion. I think second time I'm consecutively working to be work under that projectile motion. That was a super problem. My targets are future expected problems, right? But the question I expected for the future or similar type for your pure maths, applied maths, or combined mathematics or higher maths papers. Okay, see what this question says. A particle is projected under gravity from a point O. A particle is projected under gravity from a point O. If I show usual method or diagram, something like this, okay. I take the velocity u, it makes an angle alpha with the horizon, right? It's the projectile motion, one particle projected under gravity from a point O. Then you know the idea of basic projectile. Usually our recent paper, structured paper, projectile motion. Then it reached the maximum height, also horizontal range, right? Prove that the distance between the 2 points on the path. Prove that the distance of the 2 points on this path. If I mark 2 points here, 1 point here, 1 point, you know they're both symmetric, parabolic shape, right? So if I say P here, this is Q, I take the maximum height is capital letter H, draw a nice diagram, mark everything purely clearly. Check the diagram once again. The particle projected, we say your velocity u with horizontal angle is alpha. It reached the maximum height is capital H. So what the problem is, prove that the horizontal distance between the 2 points on the path, I mentioned P and Q, of the particle, which at a vertical distance above O equal to 1 over n times of the greatest height. 1 over n times of the greatest height. 1 over n times of the greatest height. This distance between that PQ equal, they say PQ equal 1 over n times of the greatest height h, capital H, is R into square. This nice problem, right? Applied always interesting problem, the application, mechanics part, mechanics, dynamics, a moving object. Is done to show that distance between the two. With the summary of the problem here, you know, the usual projectile types of shape. The distance between the P and Q, or PQ equal this answer, R into square root 1 minus 1 over n. Here actually what is the R? They say horizontal range, right? Horizontal range. What is 1 over n comes there? What the maximum height? It's 1/10 of the size. Maximum height, it's 1/10. Maybe this part, make it 1/10 of the h, okay? This also 1/10 of the h. Maximum height, 1/10 height, particle moving on its path, the distance P and Q. Okay, nice. I will show once again from the first principle method. I think you can straightly apply formula in that expression for the height and the range in applied maths. Better you follow from the first principle method. So once again, I worked the previous day before to day week that video. I have to find the capital H and capital R first, right? Okay. So copy this, apply S equal UT plus half FT square. Apply S equal UT plus half FT square. If I apply vertically, okay, apply vertically the whole motion, right? Total motion. I take time is t here, time is t here, time is 0 the projectile, okay, initially. So apply vertically full motion, 0 height, u cos alpha, then u sin alpha, okay, into t minus half gt square, okay. Therefore simplify t equal to u sin alpha over g, okay. This is the time taken to complete motion. We call flying time of the projectile, right? I need to find the capital R and the H. Now I apply the same formula horizontally. Capital R equal, range equal, u cos alpha, right? U cos alpha into t, okay. No acceleration, no force horizontally. Therefore, u cos alpha into t only. Therefore, R equal, what is that? U cos alpha into t. What is t? 2u sin alpha over g. Okay. 2u sin alpha over g. Therefore, simplify your pure mathematics. Without pure, no applied, especially trigonometry. So, you know, 2 sin alpha cos alpha sin 2 alpha and u square, right? This is the what we call horizontal, horizontal range, right? Horizontal range. Therefore, R, in this R comes that answer, that expression, right? U square, that. Okay. Now I try to find the capital height, maximum height reached by this particle. So, you know, the way apply the formula vertically, v square equal u square plus 2fs, right? Apply vertically upwards, v square equal u square plus 2fs. I take from the O to A, I take this point is A, right? O to A. Huh? The words are important, real. Follow my video series properly and copy down and take the advantage, all the nodes, what I'm telling, the conditions, points, how to apply the equations. So apply vertically O to A, write it O to A. So maximum velocity is 0. It's called peak point, right? What is vertical velocity? Here u cos alpha, u sin alpha, right? U sin alpha, all things square, minus 2gh. Therefore, dear students, what is capital H answer? Maximum height reached by the particle u square sine square alpha over 2g. Okay, this is maximum height reached by the particle, right? Okay. Now, what they said, the idea of the question is when the particle moving its path, there is a height, above the O, above the ground, or above the projectile point, one nth of the height. Okay, one nth of the height, one nth of the height. You know, every under gravity motion except the maximum point, there are two chances to reach particular height horizontally. Two height here, this same symmetric. This is 1 nth h, 1 nth h, but this is only one capital height, the biggest height, maximum height, only one possible chance, right? Okay, come back then. So therefore 1 n. Now the question is find the distance between PQ. Distance between the PQ, right? Therefore I am going to use it. Distance means velocity into time. Velocity into time, right? Now I have to apply to find the PQ answer. S equal ut plus half ft square format with the velocity into time, that case. So how to find this PQ? First we find the time difference. From here, if I say from here to here time is t1, from here to here time is t2, right? From O to P time is sorry, from O to P time is t1, O to Q time is t2. Then we can find the time between the P and Q is t2 minus t1, right? Therefore, now we can find another expression for in terms of time. Once you know the time, then you can complete the distance. Distance equal velocity into time, right? Okay. Therefore, my dear students, I try to apply the formula. Apply S equal ut plus half ft square. From O to P, generalize time is T, two parts, T1, T2. Here the height vertically upwards, the height is 1 nth of the capital H. I will apply that. 1 nth of the maximum height, right? What is velocity vertically? U sine alpha into T, okay, minus under gravity below, minus half gt square, right? You see, you can rearrange a pure mathematics work of quadratic equation here. Therefore, T has two solutions. Then you can find the T1, T2 problems. Okay. What is H? Therefore, 1 over n. It's a long work. Capital H answer, U square sine square alpha over 2g, okay, equal u sine alpha into t minus half gt square. Now multiply by the all and simplify in terms of find the quadratic equation in terms of t. Can I multiply by this 2 and g everywhere? Okay, 1 over n, 1 over n, this 2g. If I multiply all parts by that, so u square sine square alpha equal multiple 2ng here, 2ng u sine alpha. Interesting problem. Multiply LCM every part, so 2 cancel, g square, ng square is it, ng square t square, okay. Now rearrange a nice quadratic equation in terms of t. I take all here, ng square t square minus 2ng u sine alpha into t plus u square sine square alpha equal to 0, right? And g square t square minus 2ng u sine alpha t. Okay, this is a quadratic equation in t. So t has two answers. One answer t1, other answer t2. Then find the difference between the t1, t2 and go to the answer. I write the formula now. Therefore, t equal minus b plus 2ng u sine alpha minus b, right? Plus or minus square root b square, square root 4n square g square u square long work sine square alpha b square minus 4ac 4 here is ng square c, this one u square sine square alpha over 2 times a 2 times ng square. Okay, check value. It's the quadratic equation here. Give two solution. Can we simplify furthermore? T equal. See, I can cut the 2 everywhere. Is it? 2 cancel. 2 cancel. Square root 4. Take the 2 and cut it. Okay. So what the balance here? ng u sine alpha, ng u sine alpha plus or minus, okay, square root, and take some out, some more further you can take the out. I think g square can take out outside, g also can be cancelled here. G square take out, that is g, sine square alpha take out sine alpha, u square take out u, right? I think all the parts are taken out in from the into outside. Inside the n terms are remaining n square minus n. Check will you? Okay, we are focusing step by step, very close to the answer, right? Very close to the answer. So very big question, but now we have structure paper type. But you can take some advantage, opportunity, the idea from this problem series. Okay, now once again we can cut the G, I think, yes, cut the G here, 1G remaining, cut the G. Okay, then can I write straightly two answers, say T1 and T2. T2 bigger, now you can write that let the time taken to reach the P and Q R, let the time taken to reach the P and Q R, T1 and T2, right? T2 is greater than T1. I take the Q point, more time to reach the Q than P, right? Okay, therefore what is T1? T1 small answer, T2 big answer. Take the minus symbol T1. So nu sine alpha, is it okay? Nu sine alpha, nu sine alpha negative sine alpha u sine alpha within square root n square minus n over ng. I simplify 1g, right? This is T1. So what is T2? Put the plus. T2 is nu sine alpha, nu sine alpha plus u sine alpha square root n square minus n over ng, right? So what the main part here, what the difference between the time to reach P to Q? T2 minus T1. Therefore next find the T, I raise this now, okay. Find the T2 minus T1. Now find the T2 minus T1. Find the T2 minus, therefore T2 minus T1. So can I write straightly? LCM is ng nu sine alpha minus nu sine alpha cancel. this minus that. Yes, nice. 2u sine alpha within square root n square minus n. Okay. Wow, superb work. Therefore, T2 minus T1. Oh, now see, can I take the n inside? Yeah, see the answer simply like that. Put it the n inside. That is 2u sine alpha over g square root. The n goes inside the square root. That is n square. N goes inside, say n square. N square cancel 1 over n. Wow, we have the answer. This is time taken between that gap. But sometimes we can stop the future problem up to this only. But my target furthermore. So what the distance between the PQ? Okay, now apply the formula to find the distance between the PQ. Therefore, PQ equal or velocity into time. U cos alpha into T2 minus T1. U cos alpha into T2 minus T1. You know, projectile motion, horizontally velocity always remaining unaltered because of no any additional forces, extra force. Okay, so U cos alpha, what is T2 minus T1? 2u sine alpha over g with the square root 1 minus 1 over n. Okay, now there's a capital R. Go where the R? Yes, u square sine 2 alpha. U square, yeah. For super problem, dear, take the full advantage of this my video series. Subscribe and share. Take some more and more members for the maths world. Then I can show all type of questions, pure applied, all exam type future question, paper league problem, question league. Okay, thank you so much to view this video. We'll see the other day with an attractive problem series.